Okay, good. That means you have to do less work now. Okay. All right. So, yeah. All right. All right. So we have finished D last time. All right. So Nityashri, what is the status of NCRT? Okay. When you'll do that? Okay. Even after looking at that lecture? Okay, fine. All right. So today we are going to do vector very quickly, then 3D. Now, what is 3D? Three dimensional. Correct. Okay. So first, we'll quickly go through vectors. Vector is simple. Or shall we skip vector entirely? All right. So now, Murugasan, tell us what is a vector. It will have both magnitude and direction. All right. So in the chapter vector algebra, you only have dot product and cross product. All right. Remaining, I'm not doing addition subtraction because I guess that should be very easy for you guys. All right. So rather than teaching you things, we'll just take quickly one or two questions. What comes generally? All right. So before we do that, there are two important things. All of you know what is a unit vector? Christian, what is unit vector? Yeah. So a vector whose mod is 1, magnitude is 1, that's a unit vector. So let us say if I give you a vector, we are calling a vector A as I cap minus j cap plus 2k cap. So what will be its unit vector or unit vector along A? What will be unit vector along A? Yeah, we have to divide with the mod. So mod will be root 6. So what will happen? This will be like this. So we'll say A cap. A cap will be I cap minus j cap plus 2k cap divided by its mod. That is root 6. So basically you take the coefficient of I, j, k, square it and add it. All right. So easy and simple. Now next thing, important thing we talk about other type of vector is position vector. So what's a position vector? Nityashi, what's a position vector? Yeah. Like it should have a specific position. That's why we call it as position vector. Now in general, how do you determine a position? With respect to origin. So any vector whose starting point is origin is called a position vector. Now your entire 3D is based on position vector. There is no free vector. Free vector means you can move around. So free vector means moving around does not change the implication of that vector. Position vector means moving around will change the implication of the vector. All right. So can you give me an example of free vector? Yeah, like physically what it can be? Like displacement doesn't really matter, right? If I talk about displacement, I need direction and length. Now I can take origin over here, or if I say this displacement, like if you shift the origin, vector will change. So its physical implication won't change. All right, but force is a vector or scalar? Vector. Now let's say there's a rod. Origin is over here. Now if I put force here or equal force over here or over here, will have different implications, same implication. Different implications, right? So that's a position vector. Like, or you can say it's not a position vector, but it's not a free vector. It's a localized vector. Localized vector means which you cannot move. So position vector is a type of localized vector. And what kind of localized vector? We start from origin. So any vector which starts from origin. Any vector which starts from origin is a position vector. All right. Now, why it is called position vector? Because let's say if we have a point, origin is somewhere over here. So effectively, we are determining the position of this point with this vector. So it's a position vector. This vector helps us to determine the position of a point. All right. So that is why starting point will be always origin. So it always starts from origin. It always starts from origin. Now, when I say everything in 3D will be done in terms of position vector. All right. Now, why it is done like that? Because section formula. You guys know what is section formula? Tell me, please, what is section formula? Yes. Okay. Section formula is this. Let's say we have a point A having position vector A. We have a point B. Okay. What did you say? Repeat that again. All right. Yeah, that is internal and external division. Now, what kind of vector is that? That's a position vector. Because section formula only applies on the position vector, and every other derivation, like not every but almost most of the derivation, will be doing using the section formula. So that is why everything will be studying, or all the equations of plane, line, everything is based on position vector. All right, so when I say that, let's say this point C divides the line segment joining point A and B in the ratio of m is to n. Then we say this vector C, the all ABC are position vector. So vector C will be this thing, that is n times A plus m times B upon m plus n. So the section formula is varied in the position vector. You cannot randomly take for a free vector. All right. So because it is applicable on position vector, thus everything we'll be doing is position vector. Now, why section formula is correct over here, or how you will prove the section formula? How you will prove section formula, Murugasan? Everything you'll do integration in your life. Okay, what is integration of vectors? Tell me. How many times you have integrated vectors? You can also do that, but not right now in your 11th, 12th grade. All right, so we use triangle law of vector addition, easy and simple. All right, now tell me what is vector AB? In terms of B minus A? Vector AB is B minus A. Now, if I ask you, tell me vector AC. So what will be vector AC? What will be vector AC? No, C is not given. We want to find C. All right. Can I say that AC is nothing but it is AB. AB and AC are same vector in the same direction, like not same vector, same direction. The only difference is magnitude. So what is the magnitude of AB in terms of M and N? M plus N? Yeah, M plus N. Like if you take a scaling factor of anything, then M plus N is AB. And what is AC? M. So in terms of AB, when I write, can I say that AC is nothing but M upon M plus N times AB? So we can write it as M upon M plus N times B minus A. Now look at the triangle. Look at the triangle OAC. OAC. In this triangle OAC, can I use triangle law of vector addition and find out what will be OC? So what will be OC? What? Sorry, OC will be this. This is what we have to prove. Yeah. So what will be OC in triangle AOC in terms of AO and AC? It will be vector A plus vector AC, triangle of vector addition, right? It will be vector A plus vector AC. So this will be A plus will get M upon M plus N into B minus A. So when you simplify this, you'll get it as Na plus Mb upon M plus N. So basically this section formula is nothing but triangle law of vector addition. Simple. All right. And because section formula is applicable in position vector, everything is a position vector. All the equations you derive, all the equations you write for line, plane, so on. It's not a free vector. Everything is a position vector. Like some will be free vectors, but the locus. All right. So this is what we do. So this is section formula. Dot cross product shall I skip? Okay, so I'll skip dot cross product. So vector algebra is only this much. All right, vector algebra is only this much. It's not vector is finished. We'll be using vector equation in 3D. If you look at 3D chapter, you'll see all the equations of line, plane have both the forms, vector and 3D form. All right. Now, before we start all of this, Nityashi, do you know what is locus? No, that is not locus. Locus, what is locus? Murugasan, any idea? Starting point of what? What is your locus? What is your locus? Exercise 7.1. Okay, what is locus, Christian? What collection? What point? What collection? What point? Okay, I'll tell you what is locus. Locus is a fancy name of path. All right. So if I say, where do you live, Murugasan? Near where? Area. Nehru West. Okay. So let us assume that Murugasan was here. All right. He went like this, went to Kalapatti Road. He reached Citra Junction, then went like this to Civic Academy. Then you have to take a U-turn over here. Here you came to Academy. So if I ask you what was your locus, you'll say that this was your locus. This is the path followed by you. So locus is a fancy name for path. All right. Now why not call it as path? Why call it locus? Exactly. That is one of the reasons. Correct. All right. So locus is just a fancy name of path. Path under given conditions. Right. So here the condition was Murugasan wants to pick the shortest path. All right. So that was the condition. So under any given constraint, the path traced by a moving point is the locus. So locus is a path traced by a moving point. What path is tracing under a given condition? So I say circle is a locus of a point which moves at an equal distance from center. So I told you that experiment. So what is happening? This was the point. This is the path traced by it. All right. So locus is nothing but path traced by a moving point. Now under different conditions, it can move differently. All right. For example, if we give Murugasan power of flying, all right, then his path would have been this, right? So that was different conditions. All right. So this is the locus. So before we start looking about line and plane, which is the major part of your 3D, we'll understand first of all what is direction ratios and direction cosines. All right. So now, do you guys know what is slope of a straight line? What is slope, Christian? Yes, correct. But we do not talk about slope in 3D. Have you heard the term slope in 3D? You must have heard direction ratio and direction cosine, right? In the exam. I don't know whether you did it or not, the question, but you must have heard about it. So why to do direction ratios? Why not use slope again? Unnecessarily we are making things complicated. So why not use slope? Why use direction cosine or direction ratios? Okay. Now in 3D, what is the issue? You have 3 dimensions, right? Over there you had 2 dimensions. So what was happening is for 2 dimensions, slope is enough. Why slope is enough? If this would have been 2D, normal 2D will take. Then what happens? If you make an angle theta with the x-axis, by default this angle you will make pi by 2 minus theta in 2D, right? No other option. But in 3D that is not the case. In 3D that is not the case. So for example, we'll take this. Let's say you have x-axis, y-axis and z-axis coming outside. Now if I talk about this, let's say this was the line which was making some angle, right, with the x-axis. Now same, all of them make the same angle with the x-axis. All of them make the same angle with the x-axis, right? So like if you move it towards outward on z, so because slope is not good enough, slope is not good enough to determine the direction. All right, and we have talked about vector. Vector have direction and magnitude. So that is why we define something known as direction ratios and direction cosines. So that is to basically determine the direction. All right, someone asks you for direction, you will say like this, something like this, right? You go left, right. So you are telling in 2D. But let's say if Murugasan had power to fly, then if I ask for direction, he'll also say up and left and right. Right? So direction will have more dimensions to it. So that is why we define direction ratios and direction cosines to determine the direction. So first we'll look into what is direction cosine or DC. What is direction cosine? So do you guys know what is direction cosine? Actually, any idea? Yes, that's correct. So we say that, let's say if a line makes an angle alpha, beta and gamma, if a line or a vector or anything or any figure which makes an angle alpha, beta, gamma with the x-axis, y-axis and z-axis respectively, making with x-axis, this is making with y-axis, and the last one is z-axis. So in that case, direction cosine are defined as cos alpha, cos beta and cos gamma. So this is direction cosine. This is direction cosine. And we have an important result with direction cosine, that is this. Cos square alpha plus cos square beta plus cos square gamma. This is equal to 1. This is the important result. Okay. Now, why sum of square should be 1? What? 360 what? Okay, tell me 360 degree in 3D. What is 360 degree? Array in 3D, you show me what is 360 degree. In a plane 60 degrees, the one full round, right? What is in 3D? Like this. That will be sphere, right? How do you know it's 360 degrees? Alright, solid angle is not part of your syllabus. That's solid angle. Alright, so we do not study that. Now, why it is like this? Because this is nothing but distance formula. Okay, think about this. Let us say you have moved 1 unit. 1 unit. Let's say from point A to point B, and distance is 1 unit. Alright, and it makes an angle alpha with the x-axis. So tell me how much you have moved along x-axis, this distance. 1 cos alpha. This is 1 cos alpha, right? So distance moved along x-axis is cos alpha. Using same logic, distance moved along y-axis is. Array, this is not 2D, this is 3D. You are saying sin alpha because cos of 90 minus alpha, right? Because but here that the angle are not same. It is cos beta. Are you getting it or not? That is 2D what you are saying. In 3D, there is no relation between alpha, beta, gamma directly. Alright, in 2D, you can say beta is 90 minus alpha, not in 3D. Alright, so we'll say that if you are moving 1 unit on a line, let's say this length is 1 unit. So its projection along x-axis will be cos alpha, projection along y-axis will be cos beta, projection along z-axis will be cos gamma. So effectively what is happening, let's say initially if the coordinates are x1, y1, z1. So what is the change in x? Cos alpha. Change in y, cos beta. Change in z is cos gamma. So this will be x1 plus cos alpha, y1 plus cos beta, z1 plus cos gamma. Now we use normal distance formula. What will be distance between 2 points? Yes. All of you know the distance formula, right? Correct. And you get this. That's it. Easy and simple. All of you are clear on this part, Prithvin? How much clear? What? 80%. Okay. So this is about direction cosine. So direction cosine is basically help us to determine the direction. In 2D, direction is slope because they are related, interrelated. Change in x, change in y. In 3D, they are not interrelated because see, same thing which can make equal angle with x and y can make different angle with z, or same thing which makes equal angle with x can have different angle with y. So there is no direct relation. So this is the direction cosine. Next, we'll see what are direction ratios. So direction ratios, when we talk about direction ratios, is just a multiple of direction cosine. Multiple means what is the difference between a vector and a unit vector? The magnitude. Direction is same. Same is the difference between direction cosine and direction ratios. If I put ijk, for example, if I put it over here, if I write, let's say direction is this, that is cos alpha I cap plus cos beta j cap plus cos gamma k cap. So this is a unit vector. This is a unit direction vector. In terms of vector like this, in terms of 3D like this. All right. But if I take a multiple of it, any multiple, then that will become direction ratio. That will become direction ratio. And if we say that, let's say you have 2 points. You have 2 points. One point is x1, y1, z1. Other point is x2, y2, z2. So what will be the direction ratio? Direction ratio will be nothing but difference of their coordinates. So I'll write it as x2 minus x1 along x, comma y2 minus y1 along y, and Murugasan, do not sleep, z2 minus z1 along z. Or in terms of vector, this is 3D. 3D means you write in terms of coordinates, 3 coordinates, x, y, z. Vector means I cap, j cap, k cap. So in terms of vector, if I want to write, I'll say direction vector will be this: x2 minus x1, I cap plus y2 minus y1, j cap plus z2 minus z1, k cap. This is what we get. Okay, it signifies, okay, for example, here, direction cosine signifies change in x, y, and z coordinate when you are moving 1 unit. It just signifies what is the change in x, y, and z coordinate when you are moving root over x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So it signifies the change. It signifies the change in x, y, and z coordinate. That's it. This is change when you're moving unit, one unit. This is in general. It's like unit vector, same direction but some other magnitude. Alright, so it is basically used for direction. See, ultimate idea is direction. You need to know what is direction. Alright, if I say what is the direction, if I want to move from this place to this place, so I'll say take the difference of coordinates. That's it. Just like you take difference of vectors, right? B minus A. We did same thing. Clear? All of you in this part? Right, give me the NCRT ones. What?
Not ratio.
It's a ratio. It's a ratio of direction. Like, see, I'll tell you why it's called ratio. It is called ratio because we say that if this is cos alpha, cos beta, cos gamma, we are multiplying it with some constant. If you multiply with some constant, we get this. So it's a ratio. It's a ratio of x is to x, y is to y, z is to z. So this is what we have regarding the directions. All right. Now guys, that's it. That's it. It's simple. This much is exercise 11.1. All right. Now Murugasan, which question shall we take? Okay, Murugasan have become smart compared to yesterday. Okay. So that is called learning. Right? All right. So we will take up the last question from exercise 11.1. So in exercise 11.1, the last question. There are only 5 questions. That's it. Easy and simple. And the last question is this. We have to find out direction cosine of the sides of a triangle whose vertices are this. That is 3, 5, minus 4, minus 1, 1, 2, and minus 5, minus 5, minus 2. So 3 sides are there, so you have to find out direction cosine for all the 3 sides. You have to find out direction cosines for all the 3 sides. Let us give us some name. A, B, and C. Not direction ratios, but direction cosine. First find out direction ratios, then just find a unit vector or along it. Clear or not? Okay, I'll do this one. So what will happen if we talk about AB? If we talk about AB, all right. Now guys, direction you can do coordinates of A minus coordinate of B or B minus A, doesn't really matter. All right, it will represent same direction. It's a general convention that you should have more positives. then negative. Okay, so let us do A minus B because we'll get more positive. So A minus B, that means direction ratios will be 8, 10, and minus 2. This will be the direction ratios along X, Y, and Z. We've talked about this here, right? You just have to take difference of the coordinates. Difference of coordinates are direction ratios. But what we want to find out, direction cosine. So we have to divide with a mod. So if you have 8 I cap, 10 j cap, minus 2 k cap. So what is the mod of this? Mod root 168. Mod is root 168. So we'll divide with root 168. So divide with root over 168. Basically, you'll get root over 8 square plus 10 square plus 2 square. That is 64 plus 100 plus 4. So this is the direction cosine. Simple. All right. So next we'll find out for BC. For BC, Murugasan, what will be the direction ratios? Okay. 4, 6. 4, 6, 4. Now you could have also said minus 4, minus 6, minus 4. That is also correct, but always prefer taking positive ones. Right, more positives. Now, what will be the mod of this thing? Mod of BC? We'll get root over 4 square plus 6 square. So 4 square is 16 plus 16, 32, 32 plus 36 is what? It will be 68. So we'll divide with root 68. Okay. So this is what we get. Simple, right? Pretty easy. All of you are clear on this? Okay. So this is what you have to do. Now you will see question are based on find whether the points are collinear or not or so on. So if points are collinear, that means direction ratio should be like, yeah, direction cosine should be same. For example, if I take 3 points, when they will be collinear? If the direction are same. That means direction cosine of AB should be same as direction cosine of AC or BC. Then they'll be collinear like this. Collinear means same direction. All of you are clear on this? All right. So that is all about first exercise. So Murugasan, can you do the remaining 4 questions on your own? Good. All right. So now we'll move on to the equation of line. Now every equation that we will see, whether line, plane, or whatever, in all the equations we'll be seeing both vector form and 3D form. We'll see vector form and 3D form, and you have to be good at converting from one to other. They are very simple to convert from vector to 3D or 3 to vector. So we'll do derivation using vector. Then we'll convert the vector form to 3D. So let us say we want to find out equation of line. Now, to determine a unique line, what all things we require? What? Vector. Line is infinite. Like for example, if I say this is line, right? This line will go from across this building, across the earth, across the universe. Same the other end. So line length is infinite. So what all do we require? Slope is not there. Slope is okay. Or you can say direction. Direction and angle means direction. Yeah. Direction is one thing. Say like all like I'm talking about this line. or parallel lines will have same direction. So apart from that, what will you require? What intercept? It's a possible. Okay, think about this. This is x-axis, y-axis, and z-axis. Line is going like this. The line does not have any x and y intercept, right? It's going like this. Distance from origin. That we can say yes, but in that case, how many lines will have? You'll have two lines of same direction, right? Anything else? Okay, okay, what are lines you have studied in lower grade in 2D? How do you determine a unique line? 2 points. Points and slope. Same thing we'll say. Now, what replace slope in 3D? Direction. So what all do I need? Either I need either 2 points on line or 1 point and direction. Right? With this I can determine unique line. Okay, it's dropping again. What? How do you know? Okay, stop after some time. Okay. So this is all what we need. Once we have got this, we know the line. We know the line, right? But knowing the line and finding equation are two different things. So how to find out the equation? All right. Now we say that we'll do the first one when you have 2 points. So let's say 2 points are given, or we call it by name, 2 point form. 2 point form is 2 points are given. 2 point form. Now in 2 point form, let us say 2 points are given. 2 points on the line are given. Now we have talked about it. Everything we will be doing in terms of what kind of vector? Cosine is not a vector, it's cos. All right, in terms of position vector. So let's say we have one position vector, we have another position vector of this point A and the point B. All right, so if 2 points are given, that means their position vectors are given. If their position vectors are given, now we have to find out the line. Now, which line? This line, or this line? The red one. Red one is the line, not the black ones. They are position vector. I want to find this line. Now, okay, I'll ask you this question. Now, long back from grade 9th, you must have been studying equation of line in 2D. Now, Murugasan, tell me what is equation of line in 2D? What? Who knows means everyone knows, except you. Yeah, okay, tell me any line, your favorite line. Okay, I'll ask Nitesh. Tell me any equation of line. Okay. Okay. Huh? Formula means? Formula means? What is the formula of line? Arey Murugasan, what you are doing? Yeah. No. I'm just asking you any random line. Now this will be a line in 2D. All of you agree with that? Now what will be this in 3D? The 3D does not have ij. That is vector. What will be this in 3D? No. Where is k? What is k? What is this in 3D? This line. It will be a line. It will be a line. You're saying it will be a line in 3D also? No. It will change. Okay, I'll give you an example. Okay, long back when you were small kids, you studied about number line. All of you studied? So let's say this is a number line. This is a number line. There's a point on the number line. Now suddenly if I add new dimension to it, okay, let's say I'll write it over here. This is a number line. I'll remove AB. This is a number line. I want to, this is point like 0, 1, 2. Now how will I represent the point 1? I'll say x equal to 1. I'll say x equal to 1. So x equal to 1 is a point on number line. Now let us say I added a new dimension. New dimension means I made it now 2D. Now what is x equal to 1 in 2D? 1 comma 3? 0? Tell me, okay, I rephrase my question. I'll ask you, Murarasan, you draw x equal to 1 in a 2D. What you will tell me? That is fine, but x, okay. I am giving you a 2D. 2D. All right. I'll say there's a parabola. We did area, right? Parabola y square equal to 4x. Find out area bounded by y square equal to 4x and x equal to 1. So what is x equal to 1? It's a line. It has become a line. Why it has become a line? In two dimension, what you're doing, everything was points, many points. What did you do? Stretched it, everything, to make a new dimension, right? So what will happen? This point will get stretched and it will become line, right? See, it was a point. We stretched along this. It will become a line. Now I'll put a z-axis also. So what will be x equal to 1? A plane. X equal to 1 is a plane. Think about this. This is this our body. This is x-axis, y-axis. This something coming out is z-axis. All right. Now when I say x equal to 1, that means x coordinate is always 1. So this will have x coordinate 1. So initially, this is what x equal to 1 line. When I add a new dimension, it will become this plane. Every point on this plane will be x equal to 1. Clear? Now what will be this in 3D first of all? Plane. It's not a line anymore because you add a new dimension. Think about it. If it was this line, now when you put a z-axis, this line will come outside and will become a plane. All right. Okay, that is fine. Now we'll talk about this later. Okay. All right. So it looks like you do not know the basics also. Fine. No issues. Now another important question: what is x and y in this equation in 2D? Okay. Let's say this is a 2D, normal 2D. Although it won't be like this because slope is negative, but let's assume this is 3x plus 5y equal to 7. Now what is x and y? It can have infinite values, but what is that x and y in graph? Any points. X and y are coordinates of the point. X and y are coordinates of the point on the line. And any random coordinate you take, this combination will satisfy. Okay, that's why it's equation of line. So basically, equation is the relation between the x, y, and z coordinates in 3D. We'll put another z coordinate. All right. Clear all of it at this point? Okay, now where I was. Okay. Now, I want to find out equation of this line. Equation of this line. So, have you guys seen the equation of line ever in vector form? Or have you seen through question in any time in class? Or Murugasan have seen it in NCRT? So, right? So, the equation of line will be given like this. First, I'll write down the equation, then we'll understand it. R minus A equal to? Okay, Murugasan have told us the equation R minus A equal to lambda B minus A. Now tell me what is R? Required vector. What required vector? What is the required vector? Okay. R is this vector or this vector? Why second one? This one. This one coming down. Okay, what is a line? Line is a locus, a collection of points, right? A locus which has same direction. Now I've told you everything will be talking in terms of position vector. So R is position vector of any random point on the line. Right? So if I take this random point on the line, what will be the position vector? This. This is R. R is position vector of any random point on the line. So if I take any random point, then I'm talking about this position vector. So this is R, position vector. R is not line. This is the direction of line. We want to point on the line, and we are talking about is position vector. Okay, so that is what we have to do. Now, how this equation came out to be? That is triangle law of vector addition, easy and simple. Okay, now I'll name it. Let's say this is origin O, this is A, this is B, this is a random point R. The point R is moving on the line. This random point R moves on the line and trace a line. Okay, now tell me what is the vector AB? In terms of vector A and vector B. B minus A. Vector AB is B minus A. Vector AB is B minus A. Can I say that vector AR is nothing but a scaled version? All of you know what is scaling, scaled version? Scaling means I just change the magnitude. So it's a scaled version of vector AB. Now can I say that if I different scaling will give me different points on the line? Different scaling will give you different R. So how do you make different R? By multiplying it with some lambda. So I'll say different value of lambda will give me different R. Alright, if lambda is positive, I get this side. If lambda is negative, this side. If lambda is 1, this, lambda 2, this, lambda 3, this, lambda 4, this, up to infinity. Now, what do we need to find out? Position vector R. Everything is position vector. Now, can I use triangle law of vector addition? According to triangle law of vector addition, what will be R? A plus lambda times B minus A. This triangle law of vector addition, and this is your equation of line. This is the equation of line. With respect to B, oh, yeah, you can write that. You can write R equal to B plus lambda times B minus A or A minus B. Doesn't really matter, lambda will take care of it. Alright, so everything is terms of position vector. R is the position vector of a random point on the line. It is a scaling factor. Okay. If I fix lambda equal to 1, you get a point or you get a line? Point. So lambda equal to 1, 1 point, lambda equal to other point, lambda equal to 3, other point, lambda equal to 4, other point. So infinite value of lambda will give you infinite points on this line. And collection of these points is the line. That is why we leave it in terms of lambda. If I fix lambda, I get a point on the line. Okay. So this is a vector form. Now 3D form means we need something in terms of x, y, z. All right, that needs a 3D, right? Right now it's a vector. We can see a lot of vectors over here. Now how will we convert to 3D form? So first of all, let us assume that this point A have coordinates x1, comma y1, comma z1. This point B have coordinates x2, comma y2, comma z2. We have these as the coordinates. One second, guys. Okay. We have these as the coordinates. Okay. Now that we have got these as the coordinates, first of all, what will be direction of the line? What is the direction ratios between 2 points? x2 minus x1, comma y2 minus y1, comma z2 minus z1. That is the direction of line. Here, what was the direction of line? B minus a. B minus a was this thing, right? Direction of line. So first of all, we are saying this part signifies direction of line. This part signifies direction of line. All of you are clear on this? Okay. So this signifies direction of line. Now that we have got this, okay, so we have to look for the 3D form. So if it is passing through x1 comma y1 comma z and x2 comma y2 comma z, so what will be the coordinates of the variable point? X comma y comma z, because that's what we take as variable, right? Over here also we said the same thing. The coordinates of the variable point is x comma y comma z. Now we will put it over here. I can write it as xi cap. What will this become? We get xi cap plus yj cap plus zk cap. This will be equal to x1 plus y1. Okay, I have to write j cap, k cap, I cap. So A will be now x1 I cap plus y1 j cap plus z1 k cap plus lambda times. We'll get this x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. This is what we will get. This is what we'll get, right? All of you are clear on this? So this is what we will get. Now what we'll do, we can compare I with I, J with J, K with K. So when you compare I with I, both on LHS and RHS. So what will happen, comparing them I with I, compare I with I in the LHS and RHS, we will get X equal to X1 plus lambda times X2 minus X1. Or other way around, I can say that X minus X1 upon X2 minus X1 will be lambda. Same thing we can do for J cap. If we compare J cap with J cap, then we will get this Y minus Y1 upon Y2 minus Y1 equal to lambda. And comparing K cap with K cap, we will get it as Z minus Z1 upon Z2 minus Z1 is lambda. Now, all of them are equal to lambda. All of them are equal to lambda. So if all of them are equal to lambda, what we can do is we can directly equate it. We can directly equate it. So we'll say equal to this, and this will be equation of line. In fact, this is not needed. So this will be the equation of line passing through 2 points, x1, y1, z1 and x2, y2, z2. All right. So always remember that denominator x2 minus x1, y2 minus y1 and z2 minus z1. The denominator will represent what? Directions. Direction ratios along I, J, K, or x-axis, y-axis, z-axis. And it passes through the point x1, y1, z1. All of you are clear? Any doubts? Okay, then we will clear my doubt. Now, Prithvin, which one is the line? These two or these two? There are two equal to sign, right? So to find out equation of line, should I equate these two, the last two or the first two? Anything? Nityashri, any guess? Whatever coordinate I want to find. Let's say I want to find a point on the line. So whether I should equate these two or these two? What? Okay, if I equate only first two, then what will happen? I want to find a line only, right? Okay, what was linear combination coming out to be in 3D? Plane. So when you equate only any one of them, that will be a plane. If you equate these two, they will give you a. If you equate these two, you'll get a plane. So why this is the equation of line? Okay. So think about this. It's kind of this. This is one plane. This is one plane. If both the planes become equal, what do you get? What is the intersection of the plane? Line. This line. This is one plane. This is other plane, right? Intersection is this line. So if you equate only these two, you will get a plane passing through this line. If you equate these two, you get another plane passing through this line. If you equate first and last, another plane passing through this line. So you have to equate all of them together. So this equation will have how many equal to sign? 2. And till now you have been seeing only one equal to, right? Now here you have 2. So combined it is like, not independently. Independently it will become a plane. Like this. And intersection of the plane will be line. So you can think first plane, second plane, third plane. Clear? All of you on this about equation of line? Okay. Yes, that is, you told right, if one point in direction is given. So right now what was given? 2 points. Now if 1 point in direction is given, in that case we have to see how to find out line. So next what is given? We have been given 1 point and direction. So let's say direction vector is D and the point is A. Alright, so what it will look like this. A point on the line is given, this point A having vector A, and this direction D is given. So we have to find out any random point R, position vector of any random point R on the line. We have to find out position vector of any random point R on the line when a point is given, direction is given. Now in the previous case, what was the direction of the line? So how will I find out this equation? We'll just dump B minus A as, or we'll put D as B minus A. That's it. Because idea is same, right? The equation of line will be R equal to A plus lambda D. That's it. We'll look for 3D form. So in 3D form, what will happen is that in 3D form, now what will be given? A point is given. Let's say point is x1, y1, z1. Let's say this is the point. And the direction, let's say direction D is some Li cap plus Mj cap plus Nk cap. Now earlier this was the equation of line. Now what should be equation of line? See, we talked about it. X minus x1 by L. See, what was denominator? Denominator was the directions. And we are getting x1, y1, z1 already there. So if you compare it, it will be directly this. We'll get x minus x1 by L equal to y minus y1 by M equal to z minus z1 by N. So this will be the equation of line when point and direction are given. When point and direction are given. Right. All of you are clear on this? Okay. So before we move ahead, we'll take a question based on the equation of lines. Okay, so all of you do question number 4 from exercise 11.2. Try out question number 4 from exercise 11.2. So we have to see what we can do over here. Now, one second, I'll borrow the book. Let's see what is exactly question number 4. In question number 4, we have to find out equation of a line which passes through the point, 1, comma 2, comma 3, and its direct and its parallel. That means direction. Direction of the line is given as 3i cap plus 2j cap minus 2k cap. Yes, correct. So, Murugasan, what will be the equation? That is by what? 3, correct. This is equal to
y minus y plus actually y minus 2 by 2
equal to
z plus 2 by 2. I said minus of minus step. Okay. Z plus 2 by minus 2.
rather than what is this point for? Showcase.
Sorry. Z minus 3 to the minus 2.
Alright, this is what we will get. All of you are clear? Okay, now without writing, without doing anything, Priscil, tell me what will be the vector form of this line? Vector form.
R is equal to I plus 2a plus bk plus lambda times b plus a plus 2j.
Correct. Clear? What is the vector form? A plus lambda times D. Alright, so this is about equation of line. Now we'll move ahead to the next part. Alright. So in the next part, we will see what is angle between the lines. Which part is not there? Not there. Angle between lines is also not there. What about shortest distance between two lines? That is there. They are removing easy part, putting difficult part. Murugasan, you should pray that it should be the other way around. You are confident? You have seen the syllabus? You are confident, right? Okay. Shortest distance between the two lines, that is the more that should have been removed, it would have been better for you because this is very simple. That is not. Not there. Okay. No issue. Then we'll move on to the next part. That will see shortest distance between two lines. Then we'll see distance between two parallel lines. What? No, this whole exercise is all lines. This exercise is lines. This exercise is not. Exactly. So everything related to lines is this complete exercise. Angle is not there. Direct formula is very simple. Angle is simple. Very simple. All right. That is why removing angle is of no use. They should have removed shortest distance between the two lines. All right. 11.2, second question. All right. Show me what is the second question. Show that the line passing through this and this are perpendicular. No, this is angle between two lines, right? You are saying these are one line, this is one line. You have to show they are perpendicular. This is angle between lines. All right. Okay, I'll tell you it's very simple. Tell me how do you find out angle between two vectors? That's it. Do the same thing with the direction. See, direction will be determining what are the angles, right? Not the point. So you have direction of one line is D1, other is D2. Take the dot product. That's it. It's that simple. Got it right. So in this question, you can find out the direction ratios x2 minus x1, y2 minus y1, z2 minus z1 for both the lines. And if they are perpendicular, what should be the dot? 0. That's it. Simple. That's what I'm saying. Angle between two lines is very simple. Okay. So now we'll move on to shortest distance between two lines. Now we say either if two lines can be intersecting or non-intersecting. If two lines are non-intersecting, then what all can happen to the two lines? Like in which all case they can be non-intersecting when they are parallel. Anything else? Anything else? Different planes. For example, this is one line. This is another line. Are they parallel? They are parallel. You see them parallel. Parallel means they have same direction. All right. If you say this is direction, others saying this is direction. Someone asks it's parallel, they're not parallel, right? Now, are they intersecting? They can never intersect, right? Go like this or they go like this. So, what will be the shortest distance between these two? Perpendicular distance. Why perpendicular distance? That is always the shortest distance. Or I can say distance along the common normal. You know what is normal, right? What is normal, Murugasan?
Sir, I know what is now, but I cannot define what is now.
You know what is normal, but you cannot define. I'm not asking define. You tell me what do you think is normal?
So that normal is like center point, passing through the center point.
Just
So that
what is
x-axis will be a
normal force, normal thing you must have done, right? What is normal?
So that like this is x-axis, right? Then this will be a normal.
Okay. It's perpendicular to tangent. Anything which is perpendicular to tangent is normal. All right. So normal for that side is perpendicular, right? You take it perpendicular, right? Normal. Okay. So it should be along common normal. So now if I say that, then for these two lines, this will be the shortest distance along this common normal. Now normal only depend on the direction. Normal does not depend on anything, right? It will depend on direction. So I want to find out something perpendicular to this, something perpendicular to this also. If you want to find out a vector perpendicular to two vectors, two given vectors, you take cross product. You take cross product, right? So that is what we'll do. Let's say you have one line, you have another line. This line is going like, if they're not intersecting. Okay, I'll draw something else. Otherwise, you'll get confused. Let's say this is one line. This is another line. This another line is like going inside the plane. And after that, it went inside the plane. All right. So let's say shortest distance will be along common normal, which will be perpendicular to both. Because if you take any other random 2 points, it will form a right angle triangle, right? Okay, so shortest distance is along the common normal or the perpendicular one. Now what we are doing over here, let's say this line is r equal to a plus lambda b1 or a1 plus lambda b1, and let us take the other line. The other line is r equal to a2 plus lambda b2. So we have these two lines. Now for these two lines, what will be direction or what will be the common normal vector? Dot is a scalar, not a vector. Cross product of their direction. Take cross product of the direction. So cross product of direction will be b1 cross b2. It will be cross product of this. What will be unit vector or unit normal vector? By magnitude. So can I say this will be unit normal vector or the vector unit vector which is perpendicular to both? This is one line, this is one line. I got the unit vector perpendicular to both. This vector, for example. Now this will be shortest distance. Now what we will do is we'll take any two random points on the line. This one and let's say this one. These two. So can I say we need to find a projection of that on the common normal will give me distance. Projection means dot. So any 2 points. Now what are the easiest point to take? A2 and A1. So I'll take A2 minus A1. I could have taken other way around also. Doesn't matter. So its projection on this unit normal vector will give me the shortest distance. So I'll take dot. And I'll put a mod because distance cannot be negative. So this is the formula for shortest distance.
So in the exam, will be asked to always suggest the formula application.
Just the formula application.
So we should look up this formula and write.
Yes. For a term, you just have to mug up this formula. By the way, any one of you planning to write J mains? All of you are writing J mains. Good.
The J means any question they will ask like
No.
this. They won't answer.
Only chemistry is like that.
So maths and all, we can't
Maths is like, you can say 80% will be outside NCRT.
20% there also.
That's it. You want only 20% marks in J mains maths.
Yes. Say 150 only pass.
What do you do after passing marks?
Say
150 is passing mark. Who told you 150 is passing marks?
like that only they
Who is there?
say some said
What?
last year I heard some said like 150 around that.
Well, what is passing marks? You know, right? Everyone who writes J mains will get a rank. Okay, if I get minus 2 marks in J mains, I'll still get rank, some 14 lakh something. Right. So what do you mean by passing marks?
Cut off.
Cut off for?
For going into the Delhi year like
Okay, going to college. That will be around that. For NIT, Tirchi, if you are looking for. Yes, that is correct. Okay, so this is the formula. Alright, so I'll give you two random lines. You need to find out the distance. Find out this. Let's say the one line is I cap plus lambda times I cap plus j cap plus k cap. Other line is this 2 I cap minus j cap plus mu times I cap minus j cap plus 2k cap. So find out the shortest distance between these two lines. Okay, you forward the cross.
Yes, cross dot and then it corresponding by the
I'm not sure about the answer. We have to check it out. We'll solve this. So if you are doing a2 minus a1, a2 minus a1 will come out to be this. We'll get 2I cap minus j cap minus I cap. This is a2 minus a1. We have to find out b1 cross b2. So b1 cross b2 we can write like this. We can have I, j, k. We have 1, 1, 1, 1 minus 1, 2. So when we simplify this, this will come out to be as, we'll get this thing, that is 3I cap. Then for the j, we'll get it as minus j cap, and for the k, we'll get it as minus 2k cap. This is what we'll get.
The answer will be 4 by root
4 by,
So we should multiply.
what multiply? Yeah, we'll do that. So we have found b1 cross b2. b1 cross b2, we got a2 minus a1. So we'll take the dot. So this I can further write it as I cap minus j cap. So when we simplify this, we'll get it as 3 plus 1 divided by the mod of this. Mod will be how much?
40.
Root 14. So answer will be 4 by root 14. All of you are clear on this? All right, so this is what we do. And the last thing we are going to do in line is angle, sorry, distance between parallel lines. We'll see distance between parallel lines. We'll see distance between parallel lines. Now, how do we find out distance between parallel lines? So let us say one line is given like this, r equal to a1 plus lambda b1, and other we have r equal to a2 plus mu b2, sorry, mu b1. They are parallel, that means their direction will be same. So that is why both the times we have taken b1 and b1. So we have like two parallel lines. Now what we will do over here is that let us take this point is a2, this point is a1. We have this. Now this is what we have got. This is what we have got. Now what will happen? Can I say this is the shortest distance? Like whether I take over here or over here doesn't really matter, because two parallel lines, shortest distance or distance will be same between them. Now I want to find out this distance d. We want to find out this distance d. Now we'll name it. Let's say this is A, this is B, and this is C. So what will be BC by AB? If let's say this angle is theta, if this angle is theta, what will be BC by AB? It is sine theta. Sine theta. So can I say that d by mod of a2 minus a1 is sine theta? Right? So what will be the distance d? Distance d will be this mod of a2 minus a1 into sine theta. This will be the distance. This is what we'll get, right? Into sine theta. Now what is theta? Theta is angle between which two vectors? What? Theta is, what is this vector? This angle between AB and the line. It is the angle between AB and the line. What is AB vector? A2 minus A1. And what is direction of the line? B1 vector. So I can say theta is the angle between them. How do you find out angle? Dot product. Or I can also take cross product also. Cross product, but I won't take the entire vector. I just need to take the sine theta value. So we can take the mod. So what will be sine theta? Can I say over here? Sine theta is nothing but this. That is A2 minus A1 cross B1 by its mod. Like mod of individually. This is what we'll get. Now these two mod will cancel out. So finally what will be D? D will just come out to be as B1 cross A2 minus A1 by magnitude of B. And we put a mod because distance cannot be negative. We put a mod because distance cannot be negative.
So the B2 also you can take.
What?
B2 also you can take.
No, B. They are same because they are parallel. Alright, so this is all about lines. That's it. So this is the exercise 11.2, and 11.2 is purely based on lines. It's purely based on lines. So after this one, we will move on to the next one that we will see based on plane. We'll see based on plane. All right. All right. So next we will look into plane. Now we have seen how to determine a unique line. We require either 2-point or 1-point direction, like that. So now for a plane, what all do we require? Think about it. We want to determine a unique plane. So what all do we require? 3 points, correct? Why 3 points? How? Why 3 points form a plane? Okay, will 3 points form a triangle? A triangle is a plane figure. The plane of triangle will determine it. So one way is that you should have 3 points. What? 2 point and direction. What direction? What is the direction of plane? See, this whiteboard is a plane, right? So tell me what is the direction of this plane? Is direction of the plane this or this or this or this or this? Which one? This one. This one. Why not this one?
Oh, this is
Okay. So direction of plane is determined in terms of its normal. Normal means perpendicular. So what will be perpendicular? This. Direction of plane is determined in terms of the normal. See, if you think of this is the plane. This is the plane, right? So for a given orientation, direction, the normal will be different for a given orientation. If you take anything planar, then there'll be infinitely many. So direction of plane is defined in terms of normal vector. So we can say that if you have normal vector, or let's say normal vector is given. So I'll have set of parallel planes. I'll have set of parallel planes, right? So if I know a single point, let's say I'm saying only this point. So I'll get only this plane. So what else is required? Either this, or we say when a point is given and normal vector is given. When we have a point and a normal vector. When we have a point and normal vector. Third, in a similar way, we can say that when distance from origin is given, and normal vector is given. And normal vector is given. All right, so these are all the conditions. So we'll start with the second one. When let's say a point is given and normal vector is given, right? So let us say this is our plane. Now we have talked about this, that every time we'll write the equation. Equation will be in terms of what? Position vector. That means in a plane, if I talk about in a plane there'll be infinitely many position vectors anywhere on the plane, right? So we'll take a random point on the plane and we want to find out its position vector. Let's call this point as R and vector is R. Now we know a point A on the plane. Let's say this has vector A. And what else we know? We know the normal vector. So these things won't we know. Now we have to find an equation. That means a relation of R with A and N. Now if this is R vector, so this is R vector, this is A vector. So what will be the vector R minus A? Yeah, will it lie on the plane? Will R minus A lie on the plane? R minus A will lie on the plane, right? Now, if you take dot of two perpendicular vector, 0. So I'll take its dot with, and this is equal to 0, and this is the equation. This is the equation of a plane. This is what will be the equation of plane. Okay. So this is in the vector form. Next, we look into 3D form. So in 3D form, we know that ultimately we have to replace R with this. That is xi cap plus yj cap plus zk cap. This will be R. Is any given point on the plane? Let's take it as xi I cap plus x1 I cap plus y1 j cap plus z1 k cap. And n is, let's say, normal vector, which will be also given, let's say, li cap plus mj cap plus nk cap. Right, now what will be r minus a? Basically their difference. So r minus a, this vector will be this, that is x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap. Now we have to take dot with n, the normal vector. If you take dot, what will you get? Plus m times y minus y1 plus n times z minus z1 equal to 0. And this is the equation of plane. So you can clearly see what we were talking in the beginning, that a linear combination in x, y, z will be a plane, not a line. Right? It's a linear combination. Linear combination means x, y, z with power 1. So this is the equation of plane. We could have also rewrite, like if you take all the constant on one side, so we can rewrite as lx plus my plus nz. This will be equal to lx1 plus my1 plus nz1. This is what we will get. All of you clear on this? So that's it. Easy and simple. Now, why did we write like this? Because another thing you should know is coefficient of x, y, z are, that is direction. The coefficient will be always the direction. Okay. Now, before we move ahead, we'll take a question based on all of this from the NCRT. So, no, you should have read this, no? Okay. No, what? This is on entire plane, not only on this equation. All right. You want me to give an equation? Or then I do that. Then what you will do? Okay. All right. So guys, I'll give you a question. All of you try it out. You have to find out. You have to find out the vector form. Vector form of an equation of plane passing through point I cap plus j cap minus k cap and having normal vector as I cap plus j cap plus k cap. Also find out its 3D form. So find out both vector and 3D form for this one. Which one? This is 3D. This is vector.
For line also, the second term is 3D.
Second term is?
X minus x1 by x.
Yeah, that is 3D. When you write x, y, z, 3D. When you write I, j, k, vector. So you have to write both the 3D form as well as the vector form. x plus y plus z equal to 1. And what is the vector form? A vector form means you can just leave r minus a dot n. That's it. In order to simplify it.
That one is same.
What?
That will be also
Same
same.
means?
X plus y plus.
Vector means you leave in terms of vector. Do not solve it.
That one is
That only is vector.
this.
Alright. 3D means you solve it and write in terms of x, y, z. That's it. It's simple. It's two-step question. That's it. Do not overthink.
I did this in vectors. The vector from
Yeah, correct.
they both same.
I see both will be same.
Both
Plane
will-
is same, na?
Okay, this will be
See,
a vector.
okay. What do your parents call you at home?
Say my name.
Full complete name they call you,
Yes,
or you have a nickname, pet name.
Short name.
What?
Short name.
What is the short name?
RSN.
RSN. So if I say RSN or if I say Murgrasan, that will that make you different?
No.
Same thing. Leave it over here, vector form. Leave it 3D form. Alright, plane is same. Is that vector form 3D form? Plane is not changing. Okay, we'll look for the third case when distance from origin is given and normal is given. When this is given, that is distance from origin and normal. So now let us say this is our plane. This is the distance from origin d. D is the distance from origin. Alright, and we have the unit normal vector. Let's say we'll take n cap. Earlier we were taking any normal vector, right? Now we're taking n cap specifically. And we want to find out this random point r having position vector this. Alright, so now we have to see that what will be the equation of plane. Now, if I compare it with the previous form, so in the previous form we had a point on the plane. Now we have distance from origin. So using distance from origin and n cap, can I find out this point, foot of perpendicular? See, it's foot of perpendicular. Foot of perpendicular means it should be along the normal. Normal is perpendicular, right? So I know the distance d, I know the magnitude d, I know direction n cap. So what will be the foot of perpendicular, the point? Can I say this vector, if I call it d? So vector d, can I say it will be just nothing but d dot n or d n cap? D will give me the magnitude, and cap will give us the direction. This will become the position vector. Yes or no? Now rest same. Same means I'll say that r minus d n cap. This will lie along the plane. N cap is normal to the plane, so their dot should be 0. When I simplify this, I will get r dot n cap equal to d. So this is the equation. Remember here you have n cap, not vector n. Not vector n. All right. Similarly, if I talk about the 3D form, let's say n cap is given as this L I cap plus mj cap plus nk cap. Now, because it's a unit vector, so what will happen? L, m, and they will be direction cosine, not ratio. Direction cosine will ensure it's a unit vector. Direction ratio means anything can be the mod value. So they are direction cosine. So we have to do r dot d n cap this. So we'll get r dot n cap equal to d. So what we'll get? We'll get r will be obviously xi plus yj cap plus zk cap. So we will get it as lx or okay, I'll write lx plus my plus nz. This should be equal to d. This is what we will get. Now over here, important thing will be LMN, our direction cosine, not the ratios. Remember this. If you change it, you will be in big trouble. All of you are clear? Okay, so we'll take a quick question on all of this. You have to find out equation of a plane passing through the point 1 comma 1 comma 0 and having normal vector as I cap plus j cap minus k cap. You have to also find out its distance from origin. You have to also find the distance from origin. You have to also find out this distance from origin. Yeah, if it is not, then you change it. You can change it by making it a unit vector. Now it's late. Distance is root 3. What is the equation of the... Yes. Okay, so what is the equation of plane? We didn't find it out. Then how did you find out the distance? D equal to?
Lx, so 1 by root 3 into x is 1.
Okay. No, but X, Y, Z are this thing, right?
The X will be also Y also will be also Z will be given. LMN will be 1 by root 3.
Okay, you are putting the values.
Yes.
You are putting the values of X as 1 and this and this. Yeah, that is correct. Answer will be 1 by root 3. Then you are... Okay, wait a second. You are putting that value, then you are taking the dot. Okay, yeah. No. Okay, see, if that is the case, if I change the point, will distance change? According to you, if I change the point, distance will change. But distance should not change, right? See, this is the plane. This is the plane. Now, no matter which point I give you, distance of this from origin is not changing, right? Are you getting it? You find out equation first. Find out equation first. Equation. What is the equation of the plane? Okay, equation of plane will come out to be this. We'll get it as 1 into x minus x1 plus 1 into y minus y1 minus 1 into z minus z1.
But you can't substitute L and
Not
unit vector.
vector. We are finding out equation of plane. We are not talking about distance right now.
Yes, sir, where
Then you have to substitute only the direction.
What?
you said we should substitute only direction.
For distance, I'll multiply this with lambda.
So no, sir, that above equation R vector into L cap was
This is previous form. Point is given, normal is given.
so R minus A into
Yes,
D
correct. R minus A
dot of N.
equal to 0. All right.
So R minus A will be X squared.
Correct.
You will directly substitute 1, 1 and
Yes. Yes. We get this. Now what will happen? What we'll get? We'll get x plus y minus z. This is equal to 2. We get this. Now I will compare this equation with this equation. Constant can be distance d only when coefficients are, now it is direction ratio. So what will do? We'll divide with magnitude. So root 3, root 3, root 3, root 3. So what should be distance? 2 by root 3.
So yeah, so even when I did the other one, the wrong one, right, that also gave me 2 by
Yeah, that gave you, because what will happen? See, sometimes that point which is given can be foot of perpendicular, but I can also give you another point which is not foot of perpendicular. All right. So if it is foot of perpendicular, then you will get it to be correct answer. If it is any general point, you won't get a correct answer.
So what is negative?
2 by root 3.
So one more question equation.
That we practice later. All right. We do not have time for one more question. But finish two more topic quick. Only then we'll be able to done with 3D.
Sir, X and Y minus X is equal to 2, sir.
Yeah.
That is equation of plane.
Yes.
So distance from the target to plane is
2 by root 3, not 2. It is not 2 because LMN should be direction cosine. That means L square plus M square plus N square should be 1. It is not 1 right now. It is 3 if you do not take under root. So to make it 1, we are dividing everything with root 3. Got it? Okay. So this is what do we do over here. Now another next form is intercept. 3 point we are not doing because 3 point require STP and STP is out of your syllabus.
so 3 point is not there.
Yeah, know that because STP is not there, right? Scalar triple product. Scalar triple product. That is why 3 point we are not doing. We are just doing intercept form. Now every plane, like plane, will have some x, y, and z intercept. See, for example, let's say we have like this, and this is z axis. Now, if there's a plane will cut x axis at some point, y at some point, z at some point. All right. So that are known as x, y, and z intercept. Wherever it cuts x, y, and z axes. So let's say if you have x intercept as A, y intercept is B, and z intercept is C. In that case, equation of plane is given as x by A plus y by B plus z by C equal to 1. This will be the equation of plane.
அது இருக்க நான் இங்கே
வாங்க அந்த 2 லட்சம் அது வெக்டார் விட
வெக்டர் போட்டு
போட்டி அப்போ இது கூட எக்ஸைஸ்
புரியுது
அதில் பாதி டெலிவரி மெயில் வந்துச்சாப்பா ஓகே ஓகே மெயிலில் வந்துச்சா அந்த டைம் எடுத்து வச்சு எனக்கு மெயில் மெயில் அடிச்சு மெயில் அனுப்பிச்சேன்
என்ன டைட்டில்
நேற்று கேட்டு
மெயிலில்
தாண்டா எதில் வச்சியா எனக்கு மெயில் வந்துச்சு நான் என்ன பண்ண போட்டு கொடுத்தேன் சிரிப்பு காரணம்
ஏறி விட போயிட்டு பாருங்க
இல்லை எனக்கு டைம் அனௌன்ஸ் பண்ண பூனா சார் கிட்ட கால் பண்ணி சார் கண்டிப்பாக உங்களுக்கு யார் சார் மெயில் வந்துச்சு
ரொம்ப பேர் பண்ணுங்க
அவர் என்ன வந்து என்ன எழுதுன்னு சொல்லுவாங்க அவருக்கு வந்து எழுதுனா போதும்
Guys, we'll do one thing. We'll stop over here. Alright, we'll continue this later.
tomorrow.
Tomorrow we'll have online.
Then no.
Means?
So we have actually have doubt in the applications.
You have to wait a little bit. Like actually, I have to some urgent work has come. Then I'll have a class. Then after the class, I'll leave. My class will be over at 7:15. Tomorrow I won't be here. I'll be here again on Sunday. Sunday I'll be here. Tomorrow you can write mock test.
Yes, but Sunday you can take priority and this remaining.
This is very less than remaining.
Yes.
Right after 17 you can complete.
After?
8 hours.
Sir.
Okay.
You can complete it. We'll try tomorrow morning, sir.
After 7:15 anything is fine. Up to you guys. Alright. So we'll stop over here.